If you point our most sensitive instruments at the oldest, most densely packed parts of the universe, the math basically says you should be deafened.
Right. Deafened by the noise of, billions of ancient civilizations.
Yeah. But instead, you just get this completely blank wall of silence.
And honestly, that silence is the loudest thing in the cosmos. Because, when you look at the raw mechanics of star formation...
Yeah, planetary accretion and all that.
Exactly. The accretion, the chemical building blocks of life just drifting through nebulas. The universe possesses every single ingredient necessary to be this absolute riot of biological and technological activity.
Well, welcome to the Deep Dive, everyone. Today we're tackling one of the most profoundly uncomfortable documents in our stack.
Uncomfortable is definitely the right word for it.
It really is. It's an exploration of the terrifying cosmic silence. We're asking why a universe that supposedly possesses all the right conditions for life is just completely, utterly, and inexplicably quiet.
But before we spiral into the whole existential dread that naturally comes with this topic, we should probably establish the ground rules for our exploration today.
Yeah, good idea. Let's set some boundaries.
Right. So neither of us are astrophysicists. We aren't evolutionary biologists. And, we absolutely do not have the definitive answer to this paradox.
Which is fitting, honestly, because literally no one on Earth does. We're going to explore the source material honestly, critically, and just treat everything as an open question.
Yeah, exactly.
So for you listening, just know there will be no sensational, this changes everything proclamations today.
We're looking at the logic, the mathematical probability frameworks, the biological bottlenecks, and of course the terrifying possibilities that proponents of these theories argue.
We're basically treating the cosmos like an active crime scene. Because mathematically, that's what it appears to be.
It really does.
And I'll just admit right up front, looking into this topic gives me a very specific type of vertigo.
Oh, I totally get that.
Right. Like when you actually force your brain to comprehend the scale we're talking about.
Right.
The silence stops feeling like this quirk of astronomy. It starts feeling deeply personally threatening.
Yeah, the discomfort comes from the friction between what our calculations propose should exist and what our instruments actually record.
Okay, let's unpack this.
Yeah.
Because to really feel why this silence is so wrong, we have to grasp the sheer visceral scale of the universe.
Right.
And I don't want to use that tired old, count the grains of sand on a beach metaphor, because human brains just shut down when you talk about billions of anything.
They do. It's just noise at that point.
Exactly. So let's talk about the volume of light instead.
Okay, well, light speed is the ultimate speed limit of the universe, right? It travels at roughly 300,000 kilometers per second.
Which is insanely fast.
Incredibly fast.
Okay.
An estimate suggests the observable universe is about 93 billion light years across.
Which, if you think about it, means light, the fastest thing in reality, takes 93 billion years to cross the space we can currently see.
Yeah.
And within that volume, some calculations propose there are 2 trillion galaxies. Not stars, galaxies.
Islands of billions of suns.
Right. But the sheer physical volume is really only half the paradox, isn't it?
It is. The other half, the part that really creates the tension in our source material, is the timeline.
The age of everything.
Exactly. Estimates suggest the universe has been around for nearly 14 billion years.
And I really want you listening to think about what 14 billion years actually means. Because, human civilization, from the moment we figured out how to write things down in clay to the moment we split the atom, is roughly a 5,000-year span.
Right.
That is a microscopic rounding error in cosmic time.
It's nothing. Proponents of this cosmic paradox point out that if another civilization had developed just 1 million years before us, they would have an incomprehensible head start.
And a million years is like a statistical blip.
Yeah, a star system could easily form 1 billion years before ours, stabilize 1 billion years before ours, and birth life 1 billion years before ours.
And if they have a million or 1 billion year head start, the laws of exponential growth basically take over.
Right.
Even if they don't have faster than light travel. Like, let's say they just build self-replicating automated probes.
The von Neumann probe concept.
Exactly. You send out 2 probes to 2 nearby stars. They mine the asteroids, build copies of themselves, and those 4 probes head to 4 new stars.
It's a simple geometric progression. And some calculations propose that using that exact mechanism, just slow, sublight, self-replicating robotic probes, a single civilization could map and colonize every single star system in the entire Milky Way galaxy in a few million years.
Which means they should logically be everywhere. By the time human beings looked up at the sky, we should have seen a galaxy completely transformed by engineering.
We should see the waste heat of massive stellar engines. We should intercept the constant chatter of interstellar communication.
But we don't. Decades of pointing giant radio telescopes at the sky have yielded absolutely nothing. Not a signal. Not a whisper.
It's just static.
It's terrifying. It feels less like a technological limit on our end and more like a gap in reality itself. Like if you walk into a stadium built for 100,000 people during the championship game and the field is empty, the stands are empty, and you can hear a pin drop.
You wouldn't think your ears were broken.
No, you don't think, oh, maybe I'm deaf. You think something terrible happened here.
But, and I have to ask this, what if silence is completely normal and we just don't know it yet?
What do you mean?
Well, you're assuming that an advanced universe is supposed to look like human civilization.
Human civilization is literally the only one we know. Expansion, noise, consuming resources, that's what life does.
It's what adolescent life does.
Oh, interesting.
Yeah, proponents of the silence as efficiency model argue that we are projecting our own incredibly primitive, noisy phase of development onto entities that might be millions of years older.
So we're basically toddlers banging pots and pans.
Exactly. Blasting radio waves in all directions is incredibly inefficient. Building massive physical structures out of steel and glass around stars might be the technological equivalent of building castles out of mud.
So you're suggesting that a truly advanced civilization leaves no trace because they've outgrown the need to make a mess.
Right. If efficiency scales with intelligence, then the ultimate endpoint of a hyper-advanced civilization might be absolute thermodynamic perfection. No waste heat. No leaked radiation. Total silence.
Wow.
We might be looking for smoke signals in a universe communicating via fiber optics.
That's a profound transition, honestly, because this fundamental disagreement over whether the silence is a terrifying anomaly or just the natural order of physics.
Yeah.
That's exactly what drove scientists to try and quantify the unquantifiable.
Right, because you can't just look at an empty sky and shrug. You have to run the numbers.
Which brings us to a very well-known probability equation created by a renowned physicist. And the goal wasn't to spit out a definitive number of alien species, was it?
No, not at all. The goal was to create a mathematical framework to isolate our ignorance.
A logical funnel. I love that. You start with a massive scale of the galaxy, and you filter it down variable by variable until you theoretically arrive at the number of communicating civilizations currently active in the Milky Way.
Let's walk through these variables conceptually, and let's focus on the mechanisms rather than just the definitions.
That's good.
So the first variable is the rate of star formation. Estimates suggest how many new stars are born in our galaxy every year.
Okay, but stop right there. Do we actually know that? I mean, are we just guessing based on the stars nearest to us?
Actually, we have a surprisingly solid grasp on this one.
Really?
Yeah. Astrophysicists use infrared astronomy to peer through the dense dust clouds of stellar nurseries nebulas. They can observe the thermal signatures of gas collapsing under its own gravity to ignite into fusion.
Okay, so it gives us a highly reliable baseline for the galaxy's stellar engine. But a star is basically just a radioactive furnace. A star by itself is useless for biology. You need a platform, right? You need a cooling rack for complex chemistry. So variable 2, the fraction of those stars that have planetary systems.
Right. And for a long time, the existence of exoplanets was purely theoretical. We just assumed they were there.
But modern orbital telescopes revolutionized this using the transit method.
Yes, they did.
This is where it gets incredibly clever.
Yeah.
Explain how the transit method actually works, because it's mind-blowing to me that we can see rocks thousands of light years away.
Well, the trick is we don't actually see the rock.
Right.
The telescope stares continuously at a patch of sky containing tens of thousands of stars, specifically monitoring their luminosity, their brightness.
Was waiting for something to happen.
Exactly. If a planet happens to orbit that star on a plane that aligns perfectly with our telescope, the planet will cross in front of the star.
It causes an eclipse.
A microeclipse, yeah. The star's light dips by a fraction of a single percent for a few hours and then returns to normal.
And if that repeats...
Right. If that dip repeats at regular intervals, say every 300 days, you know you have a planet and you know its orbital period. You can even calculate the planet's size based on the amount of light blocked.
And based on that specific mechanism, some calculations propose that planets are not rare at all. They are the rule. The galaxy is literally choked with planets.
Billions of them.
But a gas giant made of metallic hydrogen doesn't help us. Which brings us to variable 3. How many of those planets sit in the circumstellar habitable zone?
Often referred to as the Goldilocks zone.
Right, the orbital band where the stellar radiation is just right to allow liquid water to pool on a rocky surface. Not too hot, not too cold.
Yeah.
But do we actually know how many planets meet that specific criteria? Or are we drastically oversimplifying what makes a planet habitable?
We're definitely oversimplifying. And this is where the certainty of the equation really starts to fracture.
Oh, so?
Well, proponents argue that orbital distance is just one tiny piece of the puzzle. Look at the most common type of star in the galaxy, the M dwarf, or red dwarf. They make up roughly 70% of the stellar population.
And because they're so small and cool, their habitable zone is incredibly close to the star.
Precisely. To get enough heat for liquid water, a planet has to hug a red dwarf tightly. But being that close creates a mechanical problem, tidal locking.
Like our moon.
Exactly like our moon. The star's gravity forces the planet to stop rotating relative to the star. One side faces perpetual scorching daylight, and the other side faces perpetual freezing night.
So the only potentially habitable area is a thin twilight ribbon of permanent dusk running along the Terminator line. That sounds miserable.
It does, and that's assuming the red dwarf's massive solar flares haven't completely stripped the planet's atmosphere away, which they often do.
Right.
Being in the habitable zone doesn't guarantee a biosphere. Our neighboring red planet is technically in the sun's habitable zone, but it lost its magnetosphere, the solar wind blew away its atmosphere, and now it's a freeze-dried desert.
Which forces us to look at variable 4, the spark of life.
The big one.
Right. Let's assume you have the perfect planetary platform, a robust magnetosphere, a thick atmosphere, churning oceans of liquid water. What percentage of those perfect planets actually undergo abiogenesis?
The chemical leap from non-living matter to biological life.
Exactly. What are the odds?
Yeah.
Go ahead, defend the math. Do we actually know that?
No. We are entirely in the dark. We have exactly one data point ourselves.
That is the most frustrating part of this entire framework. We don't know if life is a chemical inevitability that triggers the moment water and thermal energy mix, or if it's a freak lottery win.
It's true. Some suggest life began around hydrothermal vents at the bottom of ancient oceans, where mineral-rich, superheated water provided the energy gradient necessary to fold amino acids into self-replicating RNA.
Sounds plausible.
It does. But replicating that process, moving from a complex soup of chemicals to a membrane-enclosed cell that metabolizes energy and reproduces, we don't know the mathematical probability of that leap.
It could be 1 in a million. It could be 1 in a trillion.
Exactly.
Okay, let's play the optimist. Let's say life is common. The universe is full of single-celled organisms, alien algae, cosmic slime.
Okay.
That brings us to variable 5, intelligence. What fraction of that microscopic life evolves a central nervous system, complex cognition, and tool-building intelligence?
Again, our single data point betrays us here. We tend to view human-level intelligence as the ultimate pinnacle of evolution, like it's the inevitable destination of the biological train.
But evolutionary biology suggests otherwise, doesn't it?
It definitely does.
I mean, dinosaurs are the perfect counter-argument to the inevitability of intelligence.
Exactly. Dinosaurs dominated the terrestrial biosphere for over 150 million years. They filled every major ecological niche. They were apex predators, massive herbivores. They took to the skies. They took to the seas.
And in 150 million years, as far as we know, they never felt the evolutionary pressure to build a radio telescope or smelt iron.
Because intelligence is metabolically expensive.
Incredibly expensive.
Yes. The human brain consumes roughly 20% of our body's caloric energy, despite being a tiny fraction of our mass. Evolving a massive, energy-hungry brain is a huge risk.
So it's not a given.
Not at all. Proponents argue that intelligence might not be a common evolutionary strategy at all. It might be a highly specific, rare adaptation to extreme environmental instability.
Basically a survival mechanism of last resort for a weak, hairless primate.
Pretty much.
Okay, so even if a planet gets life, and even if that life gets smart, we hit the final brutal variable, communication. How many intelligent species develop the capacity to broadcast their existence across interstellar space?
This is a massive hurdle. A species could be incredibly intelligent, perhaps aquatic, living under the ice of a frozen moon like Europa, developing rich philosophies and complex sonar languages.
But if they live under 20 miles of ice in a liquid water ocean?
They will never discover fire. They will never smelt metal. They will never build a radio transmitter.
And even if they do, physics works against them. I mean, the inverse square law dictates that as a radio wave travels outward, its energy spreads over the surface of an expanding sphere. dropping in intensity exponentially.
Right. So a standard television broadcast from Earth, by the time it reaches a star 50 light years away, is so attenuated, so weak, that it is virtually indistinguishable from the background microwave noise of the universe.
What's fascinating here is that this probability equation doesn't fail us. It exposes us.
Yes.
Depending on the numbers you assign to these unknowns, the equation suggests there could be millions of communicative civilizations, or it could be exactly one. Us.
It forces us to confront our own ignorance. But if you take the optimistic view, if you assume that planets are everywhere, life is a chemical given, and intelligence is a persistent evolutionary outcome, the math demands that the galaxy be loud.
Which brings us to the most uncomfortable concept in our entire stack. If the math says there should be millions of civilizations, but the physical evidence confirms 0, then there is a missing variable.
A lethal one.
A lethal one. Something is actively stepping in and preventing these civilizations from making themselves known.
The great filter.
The great filter. This is an idea that some suggest explains the silence perfectly, but the mechanics behind it are incredibly ominous.
They are. If we connect this to the biological and sociological bottlenecks we just discussed, the great filter is essentially an evolutionary wall.
Right.
Proponents argue that somewhere along the vast timeline between a lifeless rock and a star-spanning galactic empire, there is a hurdle so immensely challenging or so inherently deadly that statistically almost no one survives it.
It's the ultimate cosmic bouncer. But instead of turning you away at the door, it permanently removes you from the universe.
Yeah.
The terrifying part is that we have no idea where this filter sits on the timeline, which leads us to two distinct possibilities.
Let's explore the first scenario. And for you listening, I really want you to weigh the psychological burden of this. Scenario A. The great filter is behind us.
The hopeful angle.
Sort of, yeah.
It implies that humanity has already passed the impossible test. The reason the universe is silent is because we are the freak exception to the rule. Most life fails where we somehow succeeded.
If the filter is behind us, what was it? Some evolutionary biologists argue that the leap from simple prokaryotic cells without a nucleus to complex eukaryotic cells was the great filter.
Walk me through the mechanics of that, because it highlights just how insanely lucky we might be.
Okay, look at the timeline of Earth. Basic, single-celled life emerged relatively quickly after the planet's crust cooled.
Right, almost as soon as there was liquid water.
Exactly. But for nearly 2 billion years, that life did absolutely nothing but drift and divide. 2 billion years of simple bacteria.
And then the miracle of endosymbiosis.
Yes. The theory suggests that one single-celled archaea swallowed a smaller bacterium.
As food.
As food. But instead of digesting it, a freak biological accident occurred. They fused. The smaller bacterium survived inside the larger one, providing it with massive amounts of ATP cellular energy.
And that swallowed bacterium eventually became the mitochondria.
The powerhouse of the cell.
Exactly.
That one specific, highly improbable event provided the energy architecture required for cells to build complex structures, form multicellular organisms, and eventually build nervous systems.
And proponents argue that this fusion might be the great filter.
It might be so mathematically improbable that it happened on Earth and literally nowhere else in the observable universe.
Which is comforting because it means we aren't doomed.
Right.
But it is deeply lonely. The burden of consciousness for the entire universe might rest entirely on our shoulders. If we fail, the universe loses its ability to understand itself.
That is a profound responsibility, but arguably it is vastly preferable to the alternative.
Scenario B. The filter is ahead of us.
Yeah. In this scenario, the universe is incredibly fertile. Basic life, and perhaps even early technological intelligence, is abundantly common.
The jump to multicellularity is easy.
The evolution of tool use is easy.
But something universally kills off these civilizations right before they can expand beyond their home star systems.
Right before they can become a multiplanetary species, it implies a universal trap.
Like what?
Well, every time a species reaches technological adolescence, the moment they unlock the power of the atom, the moment they gain the ability to alter their planetary climate, the moment they invent self-replicating artificial intelligence, they hit a wall.
They invent the mechanism of their own extinction before they invent the mechanism of interstellar escape.
Or perhaps an external force acts as the filter. But the implication remains. If the filter is ahead of us, then our current silence isn't a fluke. It's a waiting game.
We are happily marching toward a cliff that billions of other civilizations have already fallen off.
Exactly.
Here's where it gets really interesting. I want to bring up the thought experiment from the source text that completely rewired how I view space exploration.
Okay.
What if, tomorrow, a rover on Mars digs down into the permafrost, cracks open a rock, and finds a fossilized microbe? A tiny, long-dead, single-celled organism that has a completely different chemical structure than Earth life. It independently evolved on Mars.
Right.
Why would the discovery of alien life right next door be the absolute worst news humanity has ever received?
I really want you listening to parse the logic of this, because our immediate cultural instinct would be celebration. We would throw parades. The greatest scientific discovery in human history, we are not alone.
But follow the mechanistic logic of the Great Filter. If we find independent life on a neighboring rock in our own tiny, unremarkable solar system,
It means abiogenesis, the creation of life from non-life, is incredibly easy. It happens everywhere. Conditions are even marginally acceptable.
and if life starts easily,
Then the Great Filter cannot be behind us. The leap from chemistry to biology is not the rare miracle we hoped it was.
and if the early evolutionary steps are easy, but the night sky is still completely empty of advanced civilizations,
Then the wall that kills everyone is still waiting. It means the filter is ahead of us.
finding a fossilized microbe next door means our doom is statistically almost certain.
It guarantees that the universe is a graveyard and we are just walking through the gates.
Just let the terrifying elegance of that logic sit for a second. The idea that a microscopic fossil could serve as a death sentence for humanity's psychological future.
It's heavy.
It is. Because if the filter is real, and we haven't hit it yet, the silence of the stars is actually a warning siren.
Since we don't definitively know if the filter exists or where it lies, scientists and philosophers have proposed a spectrum of other explanations for why the universe appears so quiet.
And as we go through these proposed explanations, I want you listening to ask yourself, is this specific theory comforting, or is it terrifying?
Let the listener decide.
Exactly.
Huh.
Let's start with the first major proposition from the text. We are genuinely alone, often referred to as the rare Earth hypothesis.
We touched on this with the biological filter, but the rare Earth hypothesis extends to planetary mechanics. Some suggest that the specific physical conditions that allowed Earth to maintain a stable biosphere for billions of years are impossibly unique.
Walk through the mechanics of that, because it's not just about having water, is it?
No, not at all. Take our moon, for instance. Our moon is anomalously large compared to the size of Earth. Proponents argue that the gravitational pull of our massive moon acts as an anchor, stabilizing Earth's axial tilt over millions of years.
And without that anchor.
Without the moon, Earth's axis would wobble chaotically. It would create catastrophic climate shifts that would repeatedly sterilize emerging complex life. We'd go from ice ages to boiling oceans over and over.
Or look at Jupiter.
Exactly. Jupiter is a massive gravity well sitting in the outer solar system. It acts as a cosmic vacuum cleaner, pulling in or deflecting planet-killing asteroids and comets.
And without Jupiter running interference.
Earth might suffer an extinction-level impact every few million years, completely resetting the evolutionary clock before intelligence could ever form.
I find the rare Earth hypothesis terrifying, personally. The fragility of it all. If we are an astronomical fluke, an accident of gravitational pinball, then our existence is hanging by a thread.
See, I find it strangely comforting.
Really? How is walking a cosmic tightrope without a net comforting?
Because if we are truly alone, it means the galaxy is an empty wilderness, a blank canvas waiting for us. There are no ancient, incomprehensible alien armadas coming to colonize our world. There are no predators.
It's just us.
It's just us, the open road, and endless resources.
Okay, I see the appeal of the empty house versus a house with a stranger hiding in it.
Right.
Which brings us directly to the second explanation. They exist, but they intentionally choose silence.
This relies heavily on game theory. Some calculations propose there are much older, highly advanced civilizations out there, but they actively hide.
Why hide?
Because they view the universe not as a friendly neighborhood, but as a dark, predatory jungle.
Often called the dark forest concept.
Exactly. Imagine you are walking through a pitch-black forest at night. You are armed, but you don't know who else is in the forest, how well armed they are, or what their intentions are.
Okay.
The absolute stupidest thing you can do is light a torch and start shouting to see if anyone else is around.
Because the very first thing that notices you might be hungry or violently paranoid.
Right. Proponents of this theory argue that any civilization that survives its technological infancy quickly realizes that broadcasting your location in an unregulated universe is a fatal mistake.
Because there's no galactic police force to call.
Precisely. And the speed of light creates an insurmountable barrier to diplomacy.
Break that down for me. Why does the speed of light prevent diplomacy?
Think about it. If you detect a civilization 10 light years away, it takes 10 years for your message to reach them and 10 years to get a reply. You cannot accurately gauge their current technological capability or their intent.
They could change completely in 20 years.
Yes. So if they view you as a potential future threat, they might decide that striking first with a relativistic kill vehicle, a mass accelerated to a fraction of the speed of light, is the only logical way to ensure their own survival.
Because in a universe defined by limited resources and extreme distance, paranoia is the mathematically optimal survival strategy.
It is.
So the universe is quiet because everyone is hiding. Everyone is holding their breath, listening for a civilization foolish enough to make a sound.
And we, humanity, have been blasting our radio waves, our television broadcasts, and attaching literal maps to our home star system on space probes for decades.
We are the toddlers screaming in the dark forest.
Pretty much.
Well, that's deeply unsettling. Let's look at the third explanation. Civilizations always destroy themselves.
We brushed against this with the filter ahead of us. Some suggest that the evolutionary traits required to become an apex species, aggression, resource hoarding, tribalism, are fundamentally incompatible with godlike technology.
Yet you cannot give a tribal primate a thermonuclear weapon and expect a long-term peaceful outcome. The silence of the universe is just a graveyard of species that couldn't outgrow their evolutionary baggage.
Their biology couldn't keep pace with their physics.
It's tragic, honestly. And then there's the fourth explanation, a hostile universe. Some suggest that it's not self-destruction, but external destruction.
Right. We view the cosmos as this serene, slowly orbiting clockwork, but it is incredibly violent. Proponents argue that maybe no one survives long enough to communicate because the environment itself periodically sterilizes entire sectors.
Like the universe just actively wiping the slate clean?
Yes. Mechanisms like gamma ray bursts.
I've heard of those. How do they work?
Well, a hypernova explosion, or the merger of two neutron stars, can release a focused beam of gamma radiation. If one of those beams sweeps across a solar system, even from thousands of light years away, it strips the ozone layer from a planet and scorches the biosphere.
Just instant sterilization.
Basically. Or rogue black holes drifting through star systems, ejecting planets into deep freeze. The universe might simply be too volatile to allow for long-term galactic expansion.
It's like trying to build an intricate sandcastle right at the tide line. It doesn't matter how good your architecture is, eventually the wave always comes.
That's a great way to put it.
Let's move to the fifth explanation, which honestly feels a bit more optimistic. Maybe we are just looking the wrong way.
This raises an important question about our own technological arrogance. We are listening to the stars using radio waves. Why do we assume a million-year-old civilization uses radio?
It's like a Roman legionary trying to intercept a modern fiber optic network using a smoke signal detector.
Right.
The legionary stares at the sky, sees no smoke, and concludes no one is communicating.
That is a perfect analogy. We are looking for anomalies in the electromagnetic spectrum. Some suggest advanced civilizations might communicate using focused neutrino beams, which pass seamlessly through planets and stars.
Or gravitational waves.
Yes. They might manipulate gravitational waves. They might use quantum entanglement for instantaneous data transfer across light years.
Methods we barely comprehend theoretically, let alone possess the hardware to intercept.
They could be everywhere. The space around us could be flooded with the data streams of a galactic internet, and we are just literally technologically deaf to their frequency.
We wouldn't recognize their infrastructure even if it was draped across our solar system.
Exactly.
And speaking of things right in our own space that we don't recognize, this is where the source material takes a very sharp, very recent pivot.
Okay.
Because as we are sitting here philosophizing about a quiet, empty universe thousands of light years away, we have to address the completely unexplained anomalies happening in our own atmosphere.
No.
Major governments and militaries have recently released vast batches of declassified files, radar data, and thermal imaging of unidentified objects moving through our skies.
I need to pause us right here and be incredibly strict with the parameters of this discussion.
Of course.
This is exactly where these conversations traditionally derail into unsubstantiated speculation.
Set the boundary. I'm with you.
The sensor data and files released by these governments only confirm one specific fact: that these objects are unidentified.
Right.
They confirm that highly trained aviation personnel, backed by multi-million-dollar state-of-the-art sensor suites like forward-looking infrared and active electronically scanned array radars, have tracked physical phenomena that maneuver in ways our current understanding of aerodynamics cannot explain, period.
We don't know what they are.
Exactly. They must not, under any circumstances, be presented as proof of extraterrestrial origin. There is a vast, unbridgeable gulf between we don't know what this physical object is, and this is a craft piloted by beings from another star.
I completely respect the boundary, but I have to push back on the relevance here. As a purely analytical exercise, we are discussing the crushing silence of the cosmos, the complete lack of evidence for advanced physics out there.
Right.
And at the exact same time, we have military-grade sensor data showing physical anomalies defying known physics right here. Does the existence of things we simply cannot explain locally make this cosmic paradox more interesting, or just vastly more confusing?
I'd argue it makes it profoundly more confusing. And it serves as a necessary, humbling reality check on our technological arrogance.
How so? Walk through the physics of why these objects confuse our sensors so badly.
Well, look at the mechanisms of human flight. If human beings want an object to travel at hypersonic speeds, it requires a massive, sustained thrust mechanism, a chemical rocket or a jet turbine.
Which creates an enormous thermal bloom.
Heat, right. It also requires flight control surfaces, ailerons, rudders, flaps to push against the atmosphere. And if it breaks the sound barrier, it compresses the air and creates a massive acoustic shock wave, a sonic boom.
Action and reaction, basic Newtonian physics.
Exactly. But the declassified reports detail objects tracked by multiple independent sensor systems, radar, thermal, visual accelerating instantaneously to hypersonic speeds without a thermal exhaust plume, without wings or flight control surfaces, and without producing a sonic boom.
They are interacting with the atmosphere without suffering the friction of the atmosphere.
Which means they are utilizing a mechanism of propulsion or a manipulation of physics that we do not currently possess or fully understand. And this directly ties back to the cosmic paradox.
Because if we can't figure out how something in our own atmosphere is moving.
Precisely. If there are physical phenomena, whether they are atmospheric anomalies, black-budget drone programs, or something entirely unknown, bouncing off our most advanced military radars, and our best scientists cannot definitively identify what they are or how they move.
Right.
How incredibly arrogant is it for us to point a radio dish at a star system 10,000 light years away and definitively declare it empty?
Oh, wow. The existence of the unknown in our own backyard is proof that our toolkit for measuring reality is still in its infancy.
It really is.
We are peering through a keyhole, using a cracked magnifying glass, and confidently declaring the entire mansion to be deserted.
The inability to identify anomalies in our own lower atmosphere highlights the profound, sweeping limitations of our observational technology. It strongly supports the theory that we might simply be technologically deaf to the universe around us.
So what does this all mean? We have walked through an incredible, deeply unsettling gauntlet today.
We certainly have.
We started with a universe whose sheer physical volume and timeline virtually guarantee the existence of countless other civilizations.
We explored a mathematical framework that attempts to organize our ignorance, revealing that depending on biological variables we don't fully understand, the galaxy should either be teeming with life or entirely barren.
We confronted the looming threat of the Great Filter, the terrifying possibility that something universally slaughters intelligent life before it can expand, or the lonely hope that we are the only ones who have survived a freak biological bottleneck.
And we reviewed the proposed explanations for the silence, from the paranoia of the dark forest to the cosmic violence of a hostile universe, and the distinct possibility that we simply lack the sensory apparatus to detect the communications of older civilizations.
If we connect this to the bigger picture, whether we are genuinely alone, whether they are hiding in terror, whether they scorch their own planets in nuclear fire, or whether we just can't tune into the right frequency, the mathematical reality suggests there should have been others.
Countless others. Civilizations rising, struggling, and fading over billions of years.
Which brings us to the final question from the source material.
And it is a question that requires us to look inward rather than upward.
If every other civilization that came before us, the millions of potential societies that could have arisen over the last 10 billion years, if every single one of them eventually went silent, what does that tell us about ourselves?
No.
I know. We aren't going to answer that.
No. We can't. I explicitly do not have the answer to that, and any attempt to provide one would just be projecting human anxiety onto the cosmos. Yeah.
That is a question every person listening has to wrestle with on their own. It touches on human nature, our trajectory, our inherent flaws, and our ultimate potential to either overcome our evolutionary baggage or succumb to it.
We just have to let the immense crushing weight of that silence land.
We do.
Well, as we wrap up this deep dive, I want to leave you with a final thought. We spend so much time surrounded by the noise of our own creation, our cities, our internet, or constant frantic communication.
Right.
We expect the universe to mirror that chaotic energy. We expect the cosmos to be a crowded room. But instead, we're staring at a completely blank wall.
And a blank wall is the ultimate mirror. What we see in that profound silence usually reflects what we most fear about ourselves.
Tonight, or the next time you find yourself outside in the dark, I want you to look up at the night sky. Don't just glance at it. Really look at the space between the stars.
Let it sink in. Internalize the volume of that dark, quiet ocean stretching out for billions of light years. As you stand there, looking into the void, ask yourself, do you feel lonely or do you feel watched?
A haunting question to end on.
Thank you for joining us on this deep dive. Remember, the beauty of exploring these massive cosmic mysteries isn't in finding a neatly packaged, definitive answer. The beauty is in realizing how little we know and learning to ask better, more terrifying questions. We'll catch you next time.